Hello, dear aspirants. This is Dr. Saurav Sir's classes, and this is our contact number, which is 98367930076. Again, I am repeating it 98367930076. Please feel free to call on this number to enjoy all the services of Dr. Saurav Sir's classes, like our live classes and our doubt clearing sessions and one-on-one sessions that will help you to think in the logical way, and that will help you for the TIFR, NBHM, and all of these examinations. And we are eager to tell you that we are now organizing a batch that will help you on this exam and on these aforesaid examinations. Okay, please feel free to call on this number. So now we are going to solve a question which is appeared in the TIFR GS 2025, and the question is about the linear algebra, and the question is telling us that consider the linear map T is going from Rx to Rx, that means the polynomial of the set of the polynomials of with real coefficients defined by T of Px is equals to ddx of xpx. Then which of the following statement is correct? That our T is injective but not surjective, T is surjective but not injective, and T is bijective, and option D is telling us that T is neither injective nor surjective. So what can be done? We can say that we are tasked with analyzing the linear map, which is my this T Rx, T from Rx to Rx. Okay, let me, yeah, I think then it will be clearly visible to you. Okay, so that is defined by what? My T of Px is equals to ddx of xpx, and that is what? That is my px plus x into p dash x. So our pt of px is this. Now we are going to check the injectivity of t, that means the oneness. As our to check if t is injective, we verify that our t of p of x equals to 0 implies p of x equals to 0. Now if our t of p of x is equals to 0, then what will happen? Then we can see that our px plus x p dash x is equals to 0. Now rearranging, we will get that our p dash x will be what? That will be minus of px by x. And this is a first order linear differential equation. To solve it, then we will get p dash x by px, that will be equals to 1 by x. Okay, then what will happen? Then we will get ln of px, that will be my ln x plus ln c. Yeah, so our p of x will be x into e to the, sorry, that will be cx, and c is constant. So when our px is equals to 0, then our cx will be 0. So all of this is correct. So as our this is this, so our t is injective, we can say that. Now after that, what will happen? So now we are going to check the surjectivity of t. To check if t is surjective, we determine whether for any polynomial which is my qx belonging to Rx, then what will happen? There exists a polynomial px belonging to Rx such that our t of p of x is equals to px plus x p dash x is equals to my qx. Now rewriting that, we will get what thing? So our x p dash x is equals to my qx minus px. Now dividing through by x, valid for polynomials where our x is not equals to 0, then what will happen? P dash x will be qx minus px by x. So this is a linear first order differential equation for px, and the solution to such solutions equations exists in Rx for any qx belonging to Rx. Such our t is surjective, so both our so t is our both injective and surjective, so it's bijective as it's 1 1 and on 2. So the option C is the correct answer of this question as our t is bijective. Hope you understood, guys. Thank you. And again, I am telling that please feel free to call on this number, which is 98367 93076. That's the number of Dr. Sourabh's classes. So he will help you, or we are, and our team will help you to figure out what are the problems of your logical thinking and etc. So please feel free to call on this number. Thank you.